Hello friends, today I'm making an educational video on how to fix a refrigerant leak on this mini split system that uses R290 propane refrigerant. This system is sold in the UK and advertised as being DIY friendly, and the reason is that the refrigerant used, R290, is just ultra pure propane, so it doesn't actually technically require you to have an F-gas license to handle the gas, because it has a very low environmental impact. So the manufacturer recommends that you can actually self-install this, but they don't recommend you refill the system when there is a problem. So when I contacted the service, they recommended I should get a qualified F-gas engineer to come over and do the repair and refill the system. I would definitely recommend call a qualified contractor to do it for you. I have decided to try it myself. I'm taking all the risks. Please do not do what I'm doing, because there could be implications with your home insurance, and you definitely have to be very careful when working with flammable gases, and you have to be qualified. I'm taking my own risks, and I'm making this video for educational purposes, so please don't repeat what I'm doing. So before we begin with the repair, let's explain how do we know that something is not working well. And the obvious thing is the system is not heating or it's not cooling well. And in my case, it's basically stopped blowing any air, even though I can hear the outdoor unit working. So this is a signal that the system has issues. Another thing that I noticed, and this is also a signal that something is wrong, is the coils were actually freezing on the outside unit when it was using heating mode. So this is a suggestion that there is a very low vapor pressure, and the refrigerant is struggling to transfer heat effectively, and the best it can do is freeze over the coils. So if you see coils freezing when the temperature is not really close to freezing and your unit's not blowing very warm air, it could be a signal for a refrigerant leak. So this particular unit comes with an external connection, and because again this is propane, it's flammable, you're not allowed to make any connections internally. When I was installing this unit, I didn't have a torque wrench, so I actually must have installed this with less torque than was required. And as a result, you can see that in between the nut and the receptacle, there has been leakage by this black goo that is actually a mix of nylon blue sealant that I used to try to thread seal this, and also refrigerant oil. So this is a little bit greasy because there's been some vapor of refrigerant oil dripping. You see there's like stains of oil here. So this is a telltale sign that there's been an ongoing leak here, and it's been going for months because the system worked, and then it just stopped working maybe when the pressure dropped. Start by peeling off the layers of insulation and make sure you have enough space to work with. Be careful of the electrical wiring and the drain tubage if it's part of the line set in this case. Make sure you leave plenty of room in the exposed area so you can actually do your work. And now it's the time to start undoing the nut. You can take a normal spanner or a pipe clamp and just hold the upper nut that is fitted by the manufacturer, and you can use like a normal spanner, adjustable spanner, on the nut below. Give it a twist and be careful not to bend anything. You might hear a hiss if there's still some pressure, and at this stage I'll be definitely warning you, this is flammable, this is propane. Make sure there's no fire, there's no sparks near it, because this is a fire and explosion risk. Make sure this happens outdoors. Never do this indoors. Definitely take your time. Don't rush this. You don't want to damage those pipes. They're super delicate. So don't rush any of the steps. One thing I should definitely note is don't do this on a system that doesn't use R290. You cannot vent the refrigerant in the atmosphere. If it wasn't R290, the F gases require a license for a reason They're very potent climate change gases, so you should never do it on a system that doesn't use R290. Okay, so we're now at a stage where we have to clean up everything. Now, be extremely careful here. So you don't want any debris falling inside the pipes because it goes straight to the compressor and it can shorten the lifespan or damage it outright. So be super careful. Don't leave this out for too long because there's going to be dust getting in. Especially be careful there's no rain as well. You don't want any water getting inside. So I would use a vacuum cleaner and just suck anything that might have fallen out during the process. You can see that on my case there's like a little bit of like blue powder in here, and this is me putting nylog sealant that needs to be cleaned up. I would use a wet towel for this. So let me kick it off. But yes, these systems can be DIY'd, but a lot of HVAC installers would not be able to work on them for two reasons. One reason would be that they would say, hey, this is a DIY system, so I don't want to touch it because I don't want to be responsible for someone else's installation, which is fair enough. But the second reason is most of the avgas qualified engineers might not be qualified to also work with flammable gases. Their insurance might not cover it, etc. So that kind of really narrows down the number of engineers that can actually be willing to do a repair on your DIY system. So again, maybe it's much better for you to go and purchase just a normal system, get it installed professionally, and you don't have to worry about this. Even though this might be slightly cheaper when you DIY it, service is so much more difficult. For me personally, this is a learning experience. I find this fun, find this entertaining for myself, so I have decided to risk it and to try to DIY it and learn how to repair it as well. Because I used nylog, I'm also using a paper clip to try to scrape off any nylog that might have left. Be very careful so it doesn't drop inside the tube. Try to eject it, and definitely use a vacuum cleaner after yourself. Also, I'm going to try to make sure that there's no nylog left in any of the threads and they're as clean as they can be given the circumstances. I ended up using a small needle to clean all the nylog glue by just going through the groove carefully. If you didn't use nylog glue, you might not have to do this step. A lot of experts online say you shouldn't use nylog at all, but I'm not an expert. They're probably right. I'm still probably going to use nylog because it's just another insurance and I have time to scrape it off if I have to. It's been maybe more than half an hour, and I think I'm going to spend another 15 minutes making sure everything is clean and take a magnifying glass, make sure there's no residue anywhere in any of the threads before I proceed any further. Now it's time to make the connection again, which is the most critical point in the repair process. So I'm going to use nylog again. Don't judge me. I think this is a good insurance policy. So where you want to get some nylog on is on the threads inside, a couple of the threads, and also on the surface underneath the flaring. Now, the critical tool that I was missing last time was this torque wrench, which has an adjustable torque setting. Well, you need to make sure that you have set up your torques based on your service manual, which will tell you that for your diameter of pipe, what torque in Newton meters you want to set. In this case, I have set this just in the middle of that range, 17.5 Newton meters, because I'm sure this cheap Amazon torque wrench is not going to be very accurate, so hopefully that's going to get us at least in the correct range. I'm sure that putting nylog, which is not recommended by the manufacturer, is also going to adjust this slightly, so I don't know what's going to happen. It's still an insurance policy. let's go cracking and let's do it. Small drop goes a long way. Just make sure it's properly spread out across the whole side of it, of the thread underneath. Don't put too much. Don't put too much. Don't get anything in the inside of the nut. And once this is done, you can go ahead and apply a bunch of, like, a small bead just around the nut. Again, don't get it too much. Too much is bad. And that should be it. So now, my understanding is that there's no time to set for the nylog, so we can just go ahead and start with the main event of screwing these two items together. So yeah, take your time. Make sure you don't cross-thread this. This stage, professionals might actually do brazing or soldering instead of using a flare nut joint. I would say don't do it if you're DIY. It's very difficult. In a particular case where the refrigerant is R290, it's flammable. So you have to flush the system with nitrogen several times. This is like, brazing is not a DIY friendly method. And I know that, you know, torquing is not as good. And clearly you can see it has caused problems. For me, that's the best option as a DIY. So now it clicked. Here it's clicking. That means that we've reached the torque settings and we should let it go. So this connection should be as good as I can make it. Let's continue with the next one. The actual process here should be the same. However, it requires higher torque. So I'm just gonna go and set it up as per the manufacturer's instructions. In this case, actually, my wrench doesn't go as high as the manufacturer requires, so it's probably not going to be very accurate. I'm going to still try to torque it up based on the scale. The manufacturer requires 30 newtons, and my torque range, as you can see, goes only to around 25. I'm not sure how much you can see this, so I'm going to go past 25, which I'm sure it's not ideal. But I think at this stage, there's not many options here. All right, so now we have torqued these connections as close to the manufacturer recommendations as I can. I can see some marks I made with my tools here. Ideally, you would like to cover this with insulation, but because we don't know how good those connections are and we want to test them with some soapy water once we fill in the system, I would leave them like that. And we can move to the next step. Make sure your air conditioning is unplugged so you don't get electrocuted. You need to locate your service valve, which on this unit is over here. So to take that valve off, I would definitely recommend using a pipe clamp so we don't damage the unit. Once you've taken out the pressure, you can just remove it by hand, and you're going to confirm this is the service board by having the pin that serves for the pressure relief. So for this step, you're going to need a vacuum pump to actually take the vacuum out, and a manifold gauge set. So these items are not very expensive to obtain from Amazon. I'm going to put a link down in the description on where you can get them from. This is not an affiliate link. I'm not making any money out of this, just showing what I have. So setting up your gauge is quite easy. Only thing you might want to obtain from the internet is this service attachment for mini splits. I will provide a link again in the description. It has the pin that would activate the service port so that you can actually pump out and pump in the refrigerant. Everything else comes in the set. This item, this part, could be different for your mini split based on your model and make, so you might have to experiment and get the correct one for a use case. But let's just connect the pipes. The coloring doesn't matter, like they're all the same pipe. I'm still going to try to connect the blue to the blue side, the low side, and yellow for the middle one. And by the way, they don't explain exactly how these gauges work, but it's actually very, very simple. So there's this kind of knob controls the airflow between this port and this port. So you can connect your vacuum pump on the middle port. It's going to suck the air inside through this pipe. You can then close it, which is going to keep the vacuum here. And then once you're ready to recharge, you just connect your refrigerant to the middle line here and turn it back on. And then refrigerant is going to flow back from here to there and fill your system. This side, the high side, we don't need to use. This is used for more complicated HVAC systems for mini splits. All you need is really this low side. So here is everything connected. I just chose the blue line to match this color. Again, it's arbitrary to be honest, to be connected to the service port of the air conditioning unit. And once again, the colors don't matter. The middle port is connected to the vacuum pump over here. By the way, make sure your vacuum pump has enough oil in the indicator to make sure it doesn't run dry. But that's where we're actually ready to start sucking air. So one thing to note here is the blue line is going to stay connected to the air conditioning until we've done the whole cycle of filling in and vacuuming the gas. While the yellow line, we're going to at some point switch to the refrigerant and actually use it as a fill line to fill the refrigerant back up. So again, a huge amount of warnings here. This is propane. This is highly flammable. If you're doing it for the first time, you're going to hear the gas escaping the moment you connect this. This is dangerous. You know, there's risk of explosion, fire. I'm not qualified to give you these instructions, so you're doing this at your own risk if you're following these instructions. And you should definitely never do this for F gases, because they have environmental impact and they have to be recovered in a proper way. You should not be venting F gases in the air. However, R290 is okay because it's just propane. So with this set and checking that we've actually opened the line, don't kind of push on away and like just move it slightly back so that it doesn't get stuck. We can turn on the vacuum pump, and yeah, we're gonna see very quickly the needle moving. It's gonna hit -30. Once it hit -30, I would love to leave the pump running for maybe half an hour, just to make sure that it has evacuated everything inside. I'm going to quickly switch it off so that I can just continue talking. One thing that I didn't note is that the connectors, they're designed to be hand tight. I still do like a tiny little bit of turn with the pipe clamps. The moment I cannot hand tie them further, don't over tighten them. But the important thing is, if you have a leak in your connectors, you can't tell if the leak is actually in your system, or if it's coming from somewhere else, and you have to do a bit of troubleshooting to figure out which one it is. So that's why I want to do like a little bit of like over tightening them with a pipe clamp, but not too much, just to make sure that there's not going to be a leak in the instruments rather than the air conditioning itself. So yeah, let's continue pumping out, and we're going to be back after half an hour. Our neighbor's cat also wants to inspect the current project. Alright, so it's been half an hour. You can see the gauge has really hit the bottom there. So it's just time to turn off the pump. And now we just want to leave the system just to confirm there's no leaks. So I would close this valve to just isolate that part of the system in case there's a problem with the pump, like we don't want this to show, or they want to kind of get air sucked in. So we're closing up the system. This means that the manifold is now connected, or the gauge is now connected directly to the line set of the air conditioner, and it's showing the current pressure inside the pipe, which, as you can see, is pretty much at the minimum that this gauge can show. So it's been half an hour, and the gauge hasn't really moved perceivably. So that basically tells us there's nothing like really broken about this setup, but it can tell us that everything is okay. Professionals would have much better gauges than this one, maybe digital ones that are super expensive, so they might be able to tell a difference if there is a leak. They would also sometimes pressurize the system with nitrogen, leave it overnight, because this is a vacuum test, but it could be that the system leaked when there's pressure. Of course, as DIYers, we can't do this. So the best we can do is hope that this test is enough. And if there's another leak, well, or slow leak, it's going to show several months down the line, unfortunately. And this is where the most dangerous part, maybe the most fun part of the project comes in, where it's time to actually put in the refrigerant. So this is R290 propane refrigerant. We're actually gonna need 2 bottles. So we have 2 of them, which means that we have to change bottles in the middle of the refilling cycle, which is also quite fun. So the way we're gonna do this is we're gonna use a kitchen scale to measure the amount of propane we're gonna put in the system. We want to make sure that only the liquid part gets inside the air conditioner. So we have to flip the bottle around. So I've created a contraption out of cups to actually hold the bottle upside down. And I'm going to be using just the standard kitchen scale to confirm the amount of refrigerant that is going inside the unit. Keep in mind that we want to put the exact charge as per the service manual. So go ahead and check the service manual about the amount of charge you need to put in the air conditioner. If you have longer lines set than the standard, you might have to add additional charge. So you definitely have to insert the manual on how much of this stuff you need. For this particular R290 unit, we need 400 grams of refrigerant. And because we don't have any extra line set, this is all we need. If we had longer line set, what it came with, we have to add additional propane. But also because these bottles come on 370 grams, it means that 1 bottle is not going to be enough. So we need 2 bottles to actually fill in the unit up. So let's connect the propane bottle to the manifold in the gauges, and we can kick it off from there. And final thing, when you buy the bottle, there's going to be an option to actually buy this adapter as well. So with adapter, you can actually control when you release the gas from the bottle. Because it's pressurized, we don't need to pump it additionally. The vacuum in the system is just going to pull the liquid in, and the pressure in the bottle is going to push it out. So let me show you how you actually fill it in. So what I've just done is I've closed the valve, so we keep the vacuum. The gauge should still show minus 30 mercury. And I've taken the pipe from the vacuum pump over there and move it over to our R290 bottle. I'm wearing gloves because R290 might flash freeze you. It's very cold. It's a refrigerant, so it's being released from a high pressure to low pressure. So it's going to freeze everything it gets in touch with, including your skin. Very quick contact is probably not going to be too bad, but you should definitely not do it for too long. I'm using carton gloves, which is again not great, but it's better than nothing. So I'm going to start by releasing a little bit of gas. I'm going to open the bottle. So we're kicking it off like that. Hopefully nothing explodes. Again, this is flammable gas, guys. This is the dangerous part where you want the professional to do it. Oh, I heard a slow hiss, and the bottle is now open. And we have gas in the pipe. Now, what's important here is that we actually release a little bit of pressure. But let me first flip the bottle, put it in my makeshift holder, and try to balance it on the kitchen scale. This is not going to be exact science. Let me just see if I can get the kitchen scale to be visible, so we can tear off the kitchen scale. And before we go, let me just release a little bit of pressure. Oh, of course, I use the pipe clamp here, so I can see some some liquid getting in. So that's exciting. I'm still going to try to release just a little bit of pressure because there might have been some air in the system. Don't do it too much. So let me show you what happens when you do it. You're going to see here a hiss. You're going to see a little bit of like white smoke coming in because of the water vapor in the atmosphere actually condensing. See, there you go. Now the pipe is full of the refrigerant. You can close it up. Everything became white very quickly because it is super cold. So yeah, let's make sure we don't over tighten this. Alright, so see where we left off. We have liquid inside the holder here, and we're ready to start charging the system. We managed to release 19 grams in the air by just doing this, so let's just zero this in and let's try to get to 400. So what you're going to do is going to slowly start opening. You can see bubbles. This means we're actually charging up the system. Might want to close it up, wait for it to settle. You can see we managed to put 23 grams. Let's just keep going. You can see pressure is going up, which is exactly what we want to see. Liquid is bubbling, and we're transferring the propane in its liquid form because of the pressure through the yellow tube via the blue tube all the way to the line set. Just pause it for a second so things don't freeze over and there's some time for the gas to settle, and we keep doing this until we run out of the bottle. And the way we know we've run out of the bottle is that we're gonna start seeing much more gas than liquid inside the observation window. This is where we have to swap the bottles. I'm gonna show you later how we do this. As this bottle was used, we managed to transfer 225 grams, and there's pretty much no liquid anymore. So we finished the bottle, and there's actually no liquid at all, so well, there's maybe a tiny bit. So now it's time to swap over and transfer the rest of it from a new bottle. Be super careful. Like, this is very sketchy stuff here, right? So you want to release this propane in the air. So I would do the following just to kind of make it slightly safer. Take the bottle. It's much lighter now, so definitely we have done progress. And sorry, I'm doing it with one hand. You know, close the valve again. So I just close the valve. Make sure the valve is closed. In this case, actually opening the valve means that the valve is closed, because the way this works is there's like a small pin at the end of the bottle, and once you take this thing all the way up, it actually releases the pin, and the pin prevents the bottle from spraying. Now you have to be super careful and try to unscrew the adapter from the bottle. And I'm gonna get my gloves again and show you how this is done. Alright, so before we go, let's make sure that we're completely closing the system, so there's no way for the refrigerant to escape when we change the bottle. The system is fully closed. Getting my glove here, and I will unscrew the bottle. It's gonna hiss. Make sure there's no ignition sources where you do this, because we are venting this in the atmosphere. There you go. You can see it gets really cold very quickly. And that is it. Now we can change it to the next bottle. This one is full, so please be super careful. Okay. We're properly screwed in. Everything's closed. So I'm going to slowly release the gas back into the tube, and we repeat the whole process until we get, now I could hear the gas going in. Repeat the whole process till we get the desired amount of refrigerant in the line. When you open things fully, never open them fully. Go slightly backwards, just in case things don't get stuck. So let's continue. Alright, so same with the previous bottle. we need to bleed the system because there could be some air in it. So let's, okay, definitely don't do this. So is why you have to be super careful. So this was not tight enough. So let me make sure it is tight enough so that we don't end up in a disaster. Okay, so let's flip it over carefully. Let's bleed a little bit of the gas out once again to make sure that the pipe is full of gas. Oh, there you go. Yep, everything is frozen. My gloves are getting frozen, as you can see. Flash frozen, really. So this is dangerous. Very dangerous. And we proceed with the same exact step. Turning this off and finishing topping off. So we are now at pressure, and the system should be fully charged. So I've actually added slightly more, 10 grams more of refrigerant, because when disconnecting the service port, there's usually a little bit of flashback and we're going to lose the refrigerant. Also, we're going to lose the refrigerant that is in the line. So just to be on the safe side, I just added slightly more. Make sure you don't overfill your mini split or you're going to have bad time. The compressor is going to run. There's a lot of issues that can happen. But yeah, we're ready to disconnect. All right, so you guys are going to have a close view of this. Make sure that obviously everything else is closed. The gas bottle is closed. We can't leak any additional gas than we should. Again, we take my glove. Again, the glove doesn't really mean anything. Starting with the pipe clamp, I'm gonna slowly start taking this off. Okay, struggling a little bit here. I can probably be able to do it by hand. Oh yeah, there you go. Now it's going. It's gonna be violent, so be careful. It's gonna spray. Have to be very careful. That's it. We're done. System is venting. All the pressure. And we're finished. Again, be careful, this is propane. Like that. I think the manufacturer recommends that you torque it to the spec. And there's a valve, there's a needle inside it, so it's unlikely that you need to do it that much. But I will still torque it to spec, and our system is charged. So this is how I charge my mini split. I would not recommend you doing it. This should be done by professionals. It involves flammable gases, and there's risks. You have definitely voided your warranty now, so only do this if you know what you're doing, and don't follow my steps because I'm not a professional. I think the experts are probably screaming right now saying I shouldn't be doing this, and they're right. Listen to the experts. Hire someone to do it for you. This is just for educational purposes. However, now the system is ready and charged. We can give it a go and see if it works. Oh, one thing. Definitely check your pressure or all kind of fittings for leaks. So the unit is now working. You can see the fan going. Has a little bit of soapy water. Gonna just try to put it over the connection points. And once you pop all the bubbles, you should try to pop them. And if you see any additional bubbles, any additional bubbling happening, then you know there's a leak. In which case there isn't. So we've turned on the air conditioner on cooling mode just to check if everything works. And as you can see on the thermal imaging camera, the air conditioning is working as expected. As the mini split is in cooling mode, you can also see that the outdoor unit coil are getting warmer. Thanks for watching. Hope you got yourself entertained. The Air conditioning can also work in heat pump mode, which is what we've been using it for the whole winter, of course. So I'm looking forward to getting heat back in the conservatory because it gets really cold in the evenings as well. Alright, so see you next time.